Bismillahirrahmanirrahim. Question 18. If A and B are non-singular matrices, then show that A inverse whole inverse equals to A. Solution for the first proof. Let A be non-singular matrix, then A is non-singular, then A inverse exists such that A into A inverse equals to A inverse A equals to I. We know that when a matrix and its inverse multiplies, we get identity matrix. Implies that as these three are equal, so we are taking these two equal. A inverse A equals to I. Now shift this A inverse to the right side. So how we can shift it here? By multiplying its inverse on both sides. So we know that the A inverse whole inverse is the inverse of A. So you can pre-multiply it with A inverse whole inverse. So or you can directly will shift this here, so it will become A inverse whole inverse. So we can write it as A equals to A inverse whole inverse into I. So when it is multiplied by I, it becomes A equals to A inverse whole inverse, or write it as A inverse whole inverse equals to A. We have proved it. Look here, A inverse A equals to I. So shift it here, it become A inverse whole inverse into I. Now when it is multiplied with identity matrix, we get the same matrix. Or we can write this at this side and this at this side. And this is the result we are going to prove. Now we are going to prove AB whole inverse equals to B inverse A inverse. For this, let we take the multiplication of AB and B inverse A inverse, which equals to we can write it as A B into B inverse A inverse by associative law. When we take it in, we will take it out. Now we know that B and B inverse are the inverses of each other, so we can write it I and A inverse. Now I into A, we get A inverse. Now A inverse, we get what? I again. So by multiplying AB B inverse A inverse, we get what? I say this is 1. Now take B inverse A inverse and multiply it with AB. Again by associative law, we can write it as B inverse. Here A inverse A into B. Associative law is that when you take this in, you will take this out. Now B inverse A are the reciprocal of each other, so inverses of each other, so we can write it B inverse I into B, and I into B inverse we get B inverse B, and B inverse B again we get I. So when we now look, by multiplying these two, B inverse A inverse into AB, again we get what? I. Say this is 2. From 1 and 2 it is proved that the product of these two we get I, and the product of these two we get I. It means that AB and B inverse A inverse are inverses of each other. From 1 and 2 we get AB and B inverse A inverse are the inverses of each other. So AB into B inverse A inverse equals to I. Shift this to the right side. B inverse A inverse equals to AB whole inverse. When we shift from left side it here, so its power will become -1, and this we want to prove, and we have proved it. Question 19. A equals to this. Verify that A inverse whole transpose equal to A transpose whole inverse. For this, first find A inverse solution. For the inverse, first we find the determinant. 2, 3, minus 1, 1. 2 into 1 minus 1 into 3. 2 minus into minus plus 3, we get 5. Now adjoint of A, change the place of these two and the sign of these two. Now A inverse 1 over determinant of A into adjoint of A, 1 over 5, adjoint is 1 minus 3, 1, 2. Multiply this 5 inside here, so we get 1 over 5 minus 3 over 5, 1 over 5 and 2 over 5. This is A inverse. Now take A inverse transpose. 1 over 5 minus 3 over 5, 1 over 5, 2 over 5 transpose. So we get 1 over 5 minus 3 over 5, 1 over 5 and 2 over 5. Say this is 1. A inverse transpose. Now right side, first we will find A transpose. So 2, 3, minus 1, 1 transpose, we get 2, 3, minus 1 and 1. Now find its inverse, so A transpose determinant. 2 minus 1, 3, 1. 2 into 1 minus 3 into minus 1. 2 1s are 2 plus 3, we get 5. Now adjoint of A transpose, we get 1, 2, 1 minus 3. Now A transpose whole inverse, we get 1 over determinant of A transpose into adjoint of A transpose. So determinant of A transpose is 5 and adjoint is 1, 1 minus 3, 2. Multiply 1 over 5 here. 1 over 5, 1 over 5, minus 3 over 5, 2 over 5. This is A transpose whole inverse. Say this is 2. Now look, from 1 and 2, 1 over 5, 1 over 5, minus 3 over 5, 2 over 5, 1 over 5, 1 over 5, minus 3 over 5. From 1 and 2, we have proved that A inverse transpose equals to A transpose inverse. Proved.